Hello students, a very good day to all of you. So I hope all of you are safe and healthy. So today our topic is the electronic configuration of elements from our recent chapter, that is classification of elements and the periodicity in the properties. First of all, what is electronic configuration of elements? जब भी हम इलेक्ट्रॉनिक कॉन्फ़िगरेशन के बारे में बोलते हैं, पहले हमको ये जानना चाहिए कि इलेक्ट्रॉनिक कॉन्फ़िगरेशन है क्या। जितना भी एलिमेंट्स बच्चों पीरियोडिक टेबल में है, सारा एलिमेंट्स का एटॉमिक नंबर है। दैट एटॉमिक नंबर इज़ ऑलवेज इक्वल्स टू द नंबर ऑफ इलेक्ट्रॉन्स प्रेजेंट ऑन दैट एलिमेंट। सो जो भी एलिमेंट्स ले लो, उसका नंबर ऑफ इलेक्ट्रॉन्स को हम बोलते हैं, सॉरी, द नंबर ऑफ एटॉमिक नंबर को हम बोलते हैं दैट इक्वल्स टू द एटॉमिक नंबर ऑफ इलेक्ट्रॉन्स प्रेजेंट ऑन दैट एलिमेंट्स. Then the total electrons present on an atom are distributed in a particular design into orbitals of an atom is called the electronic configuration. यहाँ पे मैं एक डिज़ाइन ऑफ इलेक्ट्रॉनिक कॉन्फ़िगरेशन बनाई हूँ जो कि शो कर रहा है कि कैसे हम सारे ऑर्बिटल्स में हम इलेक्ट्रॉन्स को एंटर करेंगे। जैसे कि मैं लास्ट क्लास तुम लोगों को बोली थी कि एस ऑर्बिटल में मैक्सिमम 2 इलेक्ट्रॉन रह सकता है, पी ऑर्बिटल में मैक्सिमम 6 इलेक्ट्रॉन्स कैन बी स्टेड, एंड इन डी ऑर्बिटल दैट इज 10, एंड इन एफ ऑर्बिटल दैट इक्वल्स टू द 14 इलेक्ट्रॉन्स कैन बी एंटर. So we don't go on the brief introduction about the electronic configuration. In overally, this is the design of electronic configuration in which we will enter the number of electrons in the orbitals. For examples, let's start an examples with carbon, where the atomic number is 6 and the number of electrons is also 6. So according to the design of electronic configuration, we start to write the electronic configuration for carbon 1s2 because s orbitals contain maximum 2 electrons, 2s2 because that is 6 electron on the carbon atom, so we can also enter 2 electrons on the 2s, and the next 2 electrons will be entered on the 2p orbital, that is 2p2. So the total electronic configuration for carbon atom is 1s2, 2s2 and 2p2. Although the p orbitals has maximum 6 electrons, but because there are only 2 electrons left on the last orbital, so it will be entered to 2p2 orbitals. Let's start by giving another examples. For examples, potassium. Potassium has the atomic number 19, means the total number of electrons present on potassium is 19. So the electronic configuration is 1s2, 2s2, 2p6. It covers 10 electrons. After that 3s2, 3p6. It covers 18 electrons. Then after the 4s orbital comes and it contains 1 electron, that is 4s1, and the total number of electrons is now 19. So in this way we have to write the electronic configuration for various elements present on our periodic table. So let's start to our topic, how to write the electronic configuration in group. Sorry, these are in periods. So let's start to know the electronic configuration in periods. As you know, in our periodic table there are 7 periods are present. So here I am try to design some number that is called principal quantum number. Actually this portion is not covered from your atomic structure, so I am not going to details about the principal quantum number. Here I am denoting the symbol n for the number of periods. For period 1 I am symboling is n and the number is 1. If I am saying about the period 2, then n is equals to 2. and if I am saying about the period 3, then n is equals to 3. In this way we have to indicate the value of n that enters the our last electron to the outermost valence shell. So next, here I am trying to do the arrangement of arrangement of some elements with the electronic configuration, but the details you can get from periodic tables. But here I am trying to explain something, that is n is equals to 1 means this is the first period which we call k cell, because the k cell has the tendency of 2 electrons, and here it is also in our periodic tables the first period contain two elements, that is hydrogen and helium. I want to show you something here. This one is the hydrogen, because this one is the group period 1. So here it is two elements, that is hydrogen and helium, and as you know the K cell is also contain two electrons, so this one is 1 and this one is also 2, so this called the K cell also. So though it contains two elements, so it is called the K cell, hydrogen and helium. So the electronic configuration, as I am saying, that for first period, that is 1, and for first orbital, that is s, the electronic configuration for hydrogen is 1s1 and for helium is 1s2. Now let's go to the period number 2, that is L cell, which contain 8 elements. These are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. These are the 8 elements which are present on the period 2, where the electronic configuration of these elements are belongs to 2s and 2p orbitals. But the we have to go by details. Then the lithium has 2s1, beryllium 2s2. Okay, lithium has 1s2, 2s1. Okay, so barium is 1s2, 2s2. Then boron is 1s2, 2s2, 2p1. In this way we have to write the electronic configuration. So in the period number 3 there is also 8 electrons, but we can't say this is the M cell, because it contains as you know the M cell has total number of 18 electrons, but in our periodic table the M cell, we can't say the period number 3 is called M cell. Actually this contain 8 electrons. So here it is the sodium, starting from sodium to argon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon. There are 8 elements present in our group, sorry, in our period 3. Here it is okay. So next is in our period number 4 there are 18 elements are present. So here the 18 elements, I want to show you something, this one, potassium period. The 4 number periods has contain both electron elements from s orbital, p orbital and d orbital also. So it has total 18 elements, because in our s orbital there are 2 electrons, 2 elements. In our p orbital there are 6 elements, and in our d orbitals there are 10 elements. So total number of elements present in our 4 number period is contain 18 elements, and the electronic configuration belongs to the first the 4s orbitals, then the 3d orbitals, then comes to the 4p orbitals. Here I am not writing the details because it's some lengthy. If you want to write, then first orbital, first element is 4s1, then 4s2, then 3d1, then 3d2, 3d3. In this way you can write also. Next, the fifth orbitals, that is n is equals to 5, because the period number is 5. So here it is also 18 elements that starts with our 5 s orbitals and ends with 5 p orbitals. In our period number 6 there is also 32 elements present. but it also contain some inner transition elements. I want to show you something here. In this period there are 18, actually in this period there are 18 elements are present in your periodic table, but due to some reason the transition elements from lanthanum that break down and comes from the f orbitals. So the first period of your f or f block elements are belongs to the sixth period, 6 number period. So here it is 18 elements and your first period of f block element is 14, so it is combination of 32 elements. In the same way you can also explain the period number 7, that is it contain the total 18 elements, but the inner transition elements or some inner elements are present on the lanthanoid series, that is f block elements. So it is belongs to this block and this period, and it is total 18 plus 14, that is 32 elements. So here it is the arrangement where the period number 6 belongs to 6s, 4f, 5d, 6 p orbitals, and the period number 7 is 7s, 5f, 6d, and 7p orbitals. In this way we will arrange our total periodic tables according to their electronic configuration. Next one is the electronic configuration in groups. Groups means there are total 18 groups are present in our periodic table, but we have to go on the one by one. As you know, the electronic configuration, as you know, the total periodic tables are classified into 4 blocks because the last electrons enter to the same orbital or same subshell, so that belongs to the same orbitals, so same block. Here I am saying about the group 1, where the group 1 elements are called alkali metal, and the group 1 elements have the electronic configuration, all have the general electronic configuration, that is ns1, where n belongs to the period number, because you don't know the principal quantum number. So here I am saying about the period number, that is 1. If I am saying about n is equals to 3, then it is 3s1, that is sodium. In this way the total group 1 is arranged. So if you want to take any group, that is if you want to take group oxygen family, then the electronic configuration for oxygen is, first of all you have to know the general electronic configuration for the group wise. So I am saying about first group. Let's start from first group. In the first group the electronic configuration, the general electronic configuration is ns1. So for potassium, that is period belongs to 4, sorry the period belongs to 4, so the electronic configuration is 4s1. If I am saying about the argon, argon belongs to the p orbitals and the general electronic configuration is ns2 np6, where n is the 3, so 3s2 3p6 is the electronic configuration for our argon. In this way you can learn about all the electronic configuration from our periodic tables. So thank you.